In this video, we're going to discuss some further points having to do with the ellipse that we plotted in the last video. So here we have that same ellipse, and we were going to talk specifically about the points that are the foci and the co-vertex. So what I'd like you to notice is that we can draw, let me adjust the thickness of the line I'm about to draw. Okay. We can draw a line segment that goes from the focus up to this co-vertex. And notice that when we do that, we get a right triangle. Now the legs of the right triangle are the numbers that we got from our Pythagorean triple earlier. Right, the vertical leg has a length of 24, and the horizontal leg has a length of 45. And what that means is that the hypotenuse of this right triangle has a length of 51, because 24 squared plus 45 squared is equal to 51 squared. And then 51 squared, we take the square root of that, and we get 51. So let's label that. Here we are. That's 51. So, and then the horizontal leg is a length of 45, and then the vertical leg is a length of 24. Now, we can draw a second line from that co-vertex down to the other focus. And just like before, the horizontal leg is going to have a length of 45. And the hypotenuse is going to have a distance of 51. So in other words, within this ellipse is an isosceles triangle. The isosceles triangle has a base of 90, which is 45 plus 45, and the sides of the isosceles triangle are each 51, the congruent sides of the isosceles triangle. Now altogether, that means that this isosceles triangle has a perimeter of 90 plus 102. Which is 192. The perimeter of this triangle is 192. So let's clear all of this and consider another. We're going to consider another triangle, one that's not isosceles, but we're going to draw it from the foci again. So we're going to go from the focus, and let's go over to, say, this point right here. I'm not sure exactly what the coordinates of that point are, but it doesn't quite matter. And then we're going to go from that point back down to this other focus. Now, there's another triangle based on the foci of the ellipse, and going from the foci up to the point on the ellipse and then back again. Now, interestingly, the perimeter of that triangle is also going to be 192. In other words, what happens here is that the distance from the focus to the ellipse. Okay, so I'm sorry. Let me restate this. The distance from one foci to the ellipse plus the distance from the point on the ellipse to the other foci. Okay, those distances add up to the same number that we got when we drew the line from the focus up to the co-vertex and from the co-vertex over to the other focus. All right. So consequently, right, no matter what point we're on the ellipse, if we draw two line segments like this, one from the focus on the left to the point on the ellipse, and then from the point on the ellipse to the focus on the right, right? Those two distances, the lengths of those two line segments, will always add up to, in this case, 102. And it doesn't matter where we are on the ellipse. Those two distances will always add up to the same distance. Now, it turns out that that distance that those two line segments add up to is equal to the vertex, x coordinate in this case, multiplied by 2. So in other words, it's a multiplied by 2. So that distance is always 2 times a. So that's an important fact to remember about ellipses, that the line segments from each focus to a point on the ellipse add up to the same number, which is 2 times a, for every single ellipse that exists. So I hope you find this helpful, and that will be the end of this video.